All right, so we already went over what an AMU is. It is the atomic molecular unit, and it's an arbitrary standard. The standard's for all small masses. So 1 AMU is 1/12 the mass of a carbon, which has 12 atoms. 1 carbon, or carbon-12, has the mass of 12 AMU. All right, so mass number versus atomic mass. There is a difference. So the mass number is the whole number, and it specifies to only one isotope. So that 55, that's what it's talking about. But the atomic mass, or the weight, that's what you're seeing on your reference table. That is a fractional value, and it's represented by the weighted average of the naturally occurring mixture of isotopes. So you see this on your reference table. So calculating that, how the heck do we calculate this thing? An element X consists of a mixture of two isotopes. 77.5% of element X is X35, while 22.5% is X37. What is the atomic mass of element X? And identify element X. So first off, we have to assume that we have a 100 atom sample. So that makes percentages amazingly awesome. So 77.5 would have a mass of 35, and 22.5 would have a mass of 37. So if I multiply these out, I get this right here. And I would get the total of 33,543. And I just got to take the average of that mass and divide it by 100. And I get 35.4. Well, which element is 35.4? That element would be chlorine. And because that's the weight. We're looking at the weight, the AMUs, not the proton number. All right, so math could also be calculated by first converting the percentages to decimals, which makes your life a little bit easier, one less step at the end. So instead of 77.5, you have 0.775 times 35, and you have 0.225 times 37. As you can see right here, it kind of cuts that dividing by 100 down. All right, so we've got a little bit of an exercise. A newly discovered element, Z, is a mixture of 3 isotopes. The element consists of 34.60% of 284, 21.20% of 285, and the remainder is Z288. So calculate the atomic weight. First off, I'm going to get all of my numbers down. 34.6, 21.2, and then I want to calculate out my next one. So I'm going to, remember, we're taking this all out of 100, so I'm going to subtract 34.6 minus 21.2, leaves me with 44.2. And I'm going to convert these all to decimals. What I mean by that is I'm just moving it over by 2. So I have that. And you times them or multiply them by the isotope number. 284, 285, and 288. And once you do that, you can then multiply across, and you should get, okay, once you multiply across, you should come up with these numbers. All I did was multiply across, and then you're going to add them all up. 60.2 plus 98.264. You should get, hopefully, 285. You should get, hopefully, 285.98. That is the atomic weight of Z. And yep, when I round up, I get 2.86.0. Okay, solution. How the heck did I do that? So we figured out that it was 44.2 was left over because I subtracted. So I multiply across. and you should get those numbers. You're going to add all of these numbers up to equal this big old number, 28,598. And then I just have to divide that by 100 to get 285.98. And I want 4 sig figs. So 9 goes up to 10, and that's how you get that. All right, so the most common isotope. Atomic masses for the most elements indicate the element's most abundant isotope. That's the one that you find most naturally. And aluminum's is about aluminum 27. How many protons, neutrons, and electrons are in a common isotope of yttrium? The yttrium's most common isotope. So we know that there's 39 protons because that is its atomic number. Neutrons, we subtract to get 50 neutrons. And there should be 36 electrons. Remember, why was that? Sorry. So looking at our reference table, we can find that yttrium has, I got it right there, +3, which means it loses 3 electrons. It's got 3 more protons than electrons. All right, so the most common, that was the most common, just looking at that. All right, so for homework, the more atomic structures and symbols, make sure you do your study guide, because we are going to be doing, and also we're going to be starting the POGLES. So make sure you get the green pages, the study guide done. And one thing that I want to put out there is some orbitals. This is going on to the next thing. We're looking at orbitals. Electrons typically travel in pairs. If one sublevel holds more than 2 electrons, one pair in the sphere that is in the sublevel will be mathematically divided into regions. These regions are called orbitals. So it's those sublevels that are outside. We will get more on atomic theory 3. And if you have any questions, please let me know. Hope you guys have a great day.